For the first time in history, both the Hubble Space Telescope and the James Webb Space Telescope are locked on the same interstellar visitor, 3I Atlas. Not just one, but our two most powerful observatories, capturing it in visible, ultraviolet, and deep infrared light. Two perspectives, two sets of instruments, one target. Hubble, orbiting just above Earth, is mapping its coma, the vast cloud of gas and dust streaming from the nucleus. James Webb, a million miles away, is dissecting its spectrum, reading the fingerprints. This has never happened before. No other object from beyond our solar system has been studied this way, under the simultaneous gaze of humanity's sharpest eyes. And there's a reason they're both watching now. Hubble and Webb don't usually share a target. Their time is too valuable, their missions too different. But 3I Atlas is no ordinary object. Hubble, with its sharp vision in visible and ultraviolet light, is tracking the coma, the glowing halo of gas and dust that surrounds the solid core. On July 21st, 2025, it delivered the clearest image yet, a faint, ghostly envelope stretching tens of thousands of kilometers, hiding a nucleus only a few kilometers wide. From these images, scientists can measure the rate at which the object is shedding material. Estimates range from 6 to 60 kilograms per second, depending on the size of the particles. That's the weight of a car disappearing into space every minute. Meanwhile, a million miles away, the James Webb Space Telescope is seeing what Hubble cannot: the chemical fingerprint of this interstellar traveler. Webb's infrared eyes have confirmed the presence of water ice, carbon-rich dust, silicates, and complex organics, molecules that may have been frozen in place for more than 7 billion years. Together, they're giving us something we've never had before: a full spectrum profile of an object born around another star. Its composition, its activity, its behavior, all documented in unprecedented detail. From the first combined data sets of Hubble and Webb, something stood out. It wasn't a single dramatic anomaly, but a pattern of details, each small on its own, that together don't quite add up. The first surprise came from the coma. In most comets, gas and dust are pushed away from the sun by solar radiation, forming a tail that points in the opposite direction. 3I Atlas isn't following that rule. Part of its dust stream seems to angle toward the sun. That's not impossible, but it's unusual. It suggests the particles are heavier, larger than normal comet dust, and not easily pushed by sunlight. Something in its composition is resisting that force. Then came the spectral data. Webb detected water ice, expected for a comet, but also a complex mix of carbon-rich compounds and silicates. These aren't strange by themselves. What's strange is their state. They appear almost untouched by time, as if locked away from heat and radiation for billions of years. Some of these molecules could predate the sun by hundreds of millions of years. Hubble's imaging adds another layer. The coma is brighter than models predicted, but the nucleus is smaller than expected for such activity. That mismatch forces scientists to ask, is the brightness coming from something other than just reflected sunlight? Could the surface be unusually reflective? Or is there a process we don't yet understand at work here? And then there's the trajectory. While retrograde, moving opposite to the planets, it's only 5 degrees off the ecliptic plane. That's rare. Most interstellar visitors approach at steep angles, the way you'd expect from random galactic motion. But 3I Atlas is almost coplanar with our planets, as if it entered through the same corridor we send probes toward the outer system. Some dismiss this as coincidence. Others point to Avi Loeb's argument that the sequence of planetary flybys, Venus, Mars, Jupiter, has only a 1 in 20,000 chance of happening by pure chance. A statistic like that doesn't prove intent, but it does invite the question: could the unusual tail orientation, the pristine material, the bright but small nucleus, and the improbably precise path all be unrelated? Maybe. Or maybe they're the fingerprints of something we haven't seen before, either a natural process unknown to us, or something deliberately engineered. Right now, the teams working with Webb and Hubble are still collecting and processing data. But one thing is already clear. 3I Atlas is not behaving like an ordinary comet. Every observation raises a new question, and every answer seems to create two more. And soon, the chance to answer them will vanish, literally. Time is the one thing the teams at Hubble and Webb don't have. 3I Atlas is moving fast, almost 60 kilometers every second, and in just a few weeks, it will vanish behind the sun from Earth's perspective. For observatories on the ground, that means a complete blackout. For Hubble, which orbits Earth, the glare will be blinding. Even Webb, parked far beyond the moon's orbit, will have to work around dangerous pointing limits to avoid damaging its optics. That blackout will happen during its perihelion, its closest approach to the sun, the very moment when its activity will likely peak. As the heat penetrates the outer layers, hidden ices could sublimate violently, ejecting fresh material from deep inside. Each outburst could expose minerals untouched since before our sun was born. But we might not be able to see it happen. It's a cosmic paradox. The moment of greatest revelation is also the moment of greatest invisibility. There are, however, other eyes in the solar system, not pointed at 3I Atlas, but close enough to pivot. The European Space Agency's JUICE spacecraft, bound for Jupiter's icy moons, will be within just 0.3 astronomical units of the comet during part of this period. NASA's Psyche probe, on its way to a metal-rich asteroid, will also pass within a comparable range. At those distances, even a modest camera could capture details impossible to see from Earth. But there's a catch. Redirecting these missions means burning fuel reserves meant for their primary targets, rewriting navigation plans, and convincing mission teams to take a risk for an object that, officially, poses no threat. In deep space, every kilogram of propellant is survival. Every course change is a gamble. And then there's the most ambitious idea on the table, using NASA's Juno spacecraft, currently orbiting Jupiter, to stage a flyby of 3I Atlas in early 2026. The plan, proposed by Avi Loeb and collaborators, is daring. It would require Juno to slingshot around Jupiter for a massive boost, the kind of maneuver that could bring it within range of the object as it leaves the inner solar system. On paper, the math works. In reality, Juno's main engine is damaged, and its remaining fuel might not be enough for such a precision strike. Some in the community call it a brilliant use of existing hardware. Others call it reckless fantasy. But everyone agrees on one point. If it could be done, it would be our first close-up view of an interstellar visitor. And that's why the pressure is mounting. Because this isn't just another comet passing by. This is a piece of another star system. A messenger from a place we may never reach. And if it carries secrets we've never seen before, this might be our only shot to uncover them. In a few months, it will slip away. Its coma will dim, its spectrum will fade into the background noise of space, and it will become just another moving point, shrinking into invisibility until even the best telescopes in the world lose it. Once it's gone, there will be no going after it, no second chance. It's a race against celestial mechanics, against the sun itself, against the quiet indifference of the universe, and the clock is still ticking. Soon, 3I Atlas will vanish from our skies. It will swing behind the sun, hidden in its glare, and when it reemerges, it will already be on its way out, fainter, faster, slipping beyond the reach of even our sharpest instruments. A brief visitor from another star system, passing silently through our own and then gone. What Hubble and Webb are gathering right now The images, the spectra, the numbers will be the record we keep for the rest of human history. Every pixel, every spike in the data will be studied for decades. And yet, even with all this, the truth may remain just beyond our grasp. Maybe it is exactly what the cautious voices say. A comet. Nothing more, nothing less. Ancient, yes. From far away, yes. But still, just ice and rock, following the laws of physics and chance. Or maybe, buried in the patterns of light and shadow, there's something we haven't yet learned how to recognize. A deviation too subtle for the untrained eye. A signal encoded in the dust. A trajectory that was never random to begin with. If that's the case, we may not realize it now. It might take years, even decades, before someone notices the anomaly that changes everything. And when that moment comes, it will be too late to look again. Because in space, there is no rewind. The thought is humbling and a little terrifying. A piece of another world is here, within reach, and we are staring at it with everything we have. Not just to understand it, but to understand ourselves. One day, another interstellar traveler will come. Maybe in years, maybe in centuries, but it will happen. And when it does, we will remember this moment. The first time humanity's two greatest eyes worked together. Not on a galaxy far away, but on a single speck moving through our own cosmic neighborhood. If you want to be here when that next fragment arrives, subscribe. Leave a signal. Because the sky is not empty. It never was. And now, we're finally beginning to see it.